Welcome to this quantum security and defense presentation. Make quantum computing useful with performance-enhancing infrastructure software. And thank you for being a valued member of our community. Niall Moroney leads a UK-based segment of Q-CTRL Solutions team. He has a PhD in experimental quantum photonics before working in the industrial application of quantum technologies. He supports Q-CTRL's mission to make quantum technologies useful by collaborating with external organizations to identify which of their real-world problems quantum computers can solve and to help accelerate their adoption.
So yours.
Thank you, Steve. Thank you, Sylvia. Really enjoyed your talk then. Thanks everyone also for taking the time this afternoon to talk about quantum. It's great to see that there are these that the industry is developing to the point where we have these communities now interested in seeing how the whole industry is progressing. And so I'm going to talk to you about where Q-CTRL sit in this whole space. And so what I'm going to think, I'm often going to play the role of someone who, as a problem owner. So where it's somebody who they've got a problem that they think can be solved using quantum computers, and they're just on a journey to learning how they can turn their problem into a way that can actually be solved on real quantum hardware, but without needing the PhD that is required to get the best performance from that underlying hardware. And so at Q-CTRL, we're a software company. So we call what we make infrastructure software, meaning that we sit in this middle layer of the full quantum computing stack. So at the top, you can imagine we've got the end users who are interested in this, using these devices. And then from that, they then develop algorithms that they think will solve their problems and write them up in some programming framework. What they then need to do is to send it onto some physical quantum hardware, onto some qubits ultimately, to get that to get their results back. And where we sit is in that middle layer between the two. And what you can think is that we optimize the workflows such that they are most likely to get the best results back. So this all fits in quite nicely with what Sylvia was just saying, in that we've got a lot of error suppression techniques that happen within our stack. It's a bit wider information about Q-CTRL. So we're a venture capital-backed startup headquartered in Sydney, Australia, but we've got several global offices, including, so I'm in London. Well, I live in London, but we have an office in Oxford. There's also Berlin, and we've got a large team in LA and a new office just opening in San Francisco. And so we recently raised the largest Series B, I believe, for a quantum software company of just over 110 million US dollars. And you can see that throughout our life, we've worked with several partners to become very trusted. And so, yeah, these partners across government, industry, and academia. And with this, we've developed quite a strong customer base with over 10,000 users of our products. And what I really wanted to highlight as well is that there's a big number on the slide here, which is 15 billion jobs on IBM's quantum device. And so really what a lot of our value add to our customers is that they can leverage the experience that we've gained with our expertise in the device physics, along with the 15 billion jobs that we've run on IBM devices. And users can leverage that experience to get the best results for their different jobs themselves. But that's just for IBM. We do also partner with other hardware providers, other people who make quantum computers. But say, unlike Sylvia before, we do not build our own quantum computers. Instead, we integrate our software with different hardware providers.
Watch the full presentation at quantumsecuritydefense.com.